Well, I'm looking at Chapter 6.2 homework, question 22. This will look bigger for you guys. Okay, so this is about how many social ties a person has. If you want, I suggest you pause the video if you want to read through this scenario a little bit more closely. But I want to look at a social analyst estimates that on average United States adults has ties to 634 people on average. That's the keyword right there. We're looking at an average. And doing a survey of 1,700 randomly selected U.S. adults. Their cell phone users find the average number of social ties for cell phone users at 664, and then the standard deviation of 774. So what I know is there evidence that the average number of social ties for a cell phone user is different than the social analyst estimate of 634. All right, I'm going to try to use this edit box. All right, our null hypothesis in this case, we're dealing with an average. Find the mu button. All right, there you go. And we're going to assume the social analyst is true, that is 634. And the alternative, we're looking at, is it different? So we're still at mu. You just saw that. Mu. And is not equal to 634. So notice we're going to be doing a two-tail test. I want to figure out the test statistic, the p-value, conclusion for this test. All right, so I'm going to use GeoGebra. So let me open up GeoGebra. And don't forget, just Google GeoGebra and then click on probability. Once that opens, go to Statistic. And now we're going to figure out what situation we are dealing with. So right here in this situation, I have only sample data. So I only know the sample statistic and the sample standard deviation. So let me kind of write that out just to kind of talk about where do we go in GeoGebra is I think the more difficult part. But we only know sample data. In this case, it's X bar. And for my example, we're looking at my X bar is the 664. And then sample standard deviation, S, that is the 778. I'm up with my sample size here of 1,700. So since we only know sample data, we need to use a t test of a mean. So inside GeoGebra, we only know sample data. So I'm going to use the t-test of a mean. So in GeoGebra, I'm going to click right here and change that from a z-test to a t-test. Although once we finish this, I want to show you actually in this particular case, it doesn't matter. But I think it's a little bit simpler just to make it straightforward. If we only know sample data, we're going to use the t-test. All right, so then we got to enter the null hypothesis. I think this was 634. Make sure I don't get that wrong. 634 for the null hypothesis. Alternative is a not equal. And the mean was, I think, 664. I want to double check that. 664. And standard deviation of 778. And sample size N, that was 1,700. Yep, 1,700 random adults. All right, so test statistic, p-value, and conclusion. So my test statistic is T or Z. In this case, we're using the t-test. So it's 1.5899. Excuse me. So we want to go to 2 decimals. 1.5899, rounded to 2 decimals. Strange. 1.59, test statistic. So I have problems with my keyboard. And p-value is given to be 0.112. And that want that rounded to 3 decimals, 0.112. All right, so p-value, then the conclusion, do we reject or not reject? And I want to check to see if we're given a significance level. Since we are not given a significance level, I'm just going to put right here, p-value is 0.110. Since we're not given significance level, which is the notation would be alpha, we assume it's 5% or 0.05. So I always make that assumption unless we're given specifically a significance level. Check. Yep, we're not given anything. So my p-value here is greater than 5%, so we do not reject. Does the sample provide evidence that the average number of social ties is significantly different? That would be no. There's some evidence, but not a lot of evidence. Check the answer, and you see we got this correct. So I want to go back and note that in here, when you have such a large sample size, it actually doesn't matter generally if you use T or Z. Most statisticians say if you have a couple hundred in their sample size, you could pick either one, ends up being the same. I'll show you what I mean. So if I go to Z, notice right here, 1.59 and 0.112, round this to 2 decimals. So notice right here, the sample statistic and the p-value are actually identical if you round it to the correct decimals. So if you have a very large sample size, let's say more than 1,000, it doesn't matter which one you use, Z versus T. But if you think that's going to confuse you, just go with the idea if we only know sample data, then you're looking at a t-test.